So hello everyone, welcome back to another particular lecture series of our reagent chemistry course, and this is the class 15. So here we are talking about the Gilmann reagent. So in our previous discussion, that is a class 14, we are talking about the organomagnesium based reagent. Now here we are talking about the organocopper based reagent, that is the Gilmann reagents. So first let us talk about the Gilmann reagent, Gilmann reagents, that also known as the lithium organocopper reagent. It is written like this: R2CuLi are organocopper compound used in organic synthesis to facilitate nucleophilic attacks on electrophiles. They are particularly effective for a coupling reaction and the selective alkylation of various electrophile, making them valuable in forming carbon-carbon bonds. So this is the structure of Gilmann reagent. This is given in your exam, R2CuLi, or sometimes it is written as something like this, that RMGX and CuLi. If this thing is given in your exam, then never approach the question as a Grignard one. Remember that this composition will always give a Gilmann reagent. Okay, and due to this copper present, the resulting nucleophile, that is R minus, generated from the Gilmann reagent is a soft nucleophile, and it is mainly for favored 1,4 attack in presence of alpha beta unsaturated carbonyl compound. So we'll discuss in the later slides. So other form is, if it is written like this, RLiCuI, then don't treat this as a organolithium reagent. It is also a form of Gilmann reagent, or sometimes written this form also. So Gilmann reagent written form is different, but you have to remember that when the copper is present there, that means the reagent is Gilmann reagent. And now let us talk about the Gilmann reagent preparation. There is a reagent. So in contrast to Grignard and organolithium reagent, organocopper reagents cannot be made directly through treatment of alkyl or alkyl halides. Like previously we have seen that alkyl halides are actually treated with magnesium to get the corresponding Grignard. Similar thing is observed in the organolithium base also. The organic halide react with the lithium to get organolithium, but this is not possible in terms of Gilmann reagent preparation, because this particular reaction is not happen because the copper is a not strong reducing agent, and that's why they can't cleave this particular bond and doesn't replace directly. That's why Gilmann reagents are made by treating one equivalent of a copper salt with two equivalent of organolithium species. So initially this alkyl halides are treated with lithium to make their corresponding organolithium compound. Now this two equivalent of organolithium react with the copper bromide in presence of ether solvent to generate the Gilmann reagent. This is the R2CuLi, and this is the composition of the Gilmann reagent, and lithium bromide is the salt, is the byproduct of this particular reaction. So this is the Gilmann reagent. Now let us talk about different Gilmann reaction. So Gilmann reagent shows two different type of reaction. One is the addition reaction, one is the substitution reaction. In addition reaction, there is a two type of addition is there. One is the addition of carbonyl, and another is a Michael addition. There is a 1,4 addition. Since Gilmann reagent generates soft nucleophile, that's why it will show 1,4 addition. It doesn't show 1,2 addition in presence of alpha beta unsaturated carbonyl compound. But in the case of normal carbonyl compound, it will react similar like 1,2 addition takes place. I will discuss in the next slide. And also Gilmann will show another type of reaction, that is a substitution reaction, SN2 type of reaction, that will proceed this type of reaction via question answers. Okay. Now let us talk about the addition reaction of carbonyl compound. That this is the acid chloride. Acid chloride react with the Gilmann reagent. Gilmann reagent generates the R minus here, and that particular R minus are actually attack in the carbonyl carbon. This one goes up, this goes back, and this particular chlorine goes out of the starting material, and we finally get this particular compound. So this is the 1,2 addition product. Similarly, in the case of aldehyde and ketone also, Gilmann reagent will show 1,2 addition reaction and generates this tertiary alcohol. But when the alpha beta unsaturated carbonyl compound is there, this type of thing, then Gilmann reagent show 1,4 addition. That R minus will then attack here. This is because the particular copper is a soft nature and this particular center is a soft center. And this particular carbonyl carbon center is a hard center. So since the nucleophile is soft, then soft interaction takes place, and that's why this 1,4 addition felicitated here. Also, it contains certain stereochemistry, like when a directing group present in terms of 1,4 addition process, like here, this is the directing group, it is present in the F of the plane reaction. So initial attack, the initial R minus, the methyl minus nucleophile attack from the backside one to eliminate the steric repulsion, and to 1,4 addition takes place and this particular intermediate is generated. Then this negative charge goes back, and in presence of different electrophile present here, it will react here, and then this particular stereochemistry will be opposite of the initial R group stereochemistry. Like here, the methyl group attack in the lower side, and then due to the influence of this bulky group to eliminate the steric repulsion. After that, to eliminate the steric repulsion, this electrophile will have the opposite symmetry, like it will attack from the above the plane to eliminate the steric repulsion between this group and this group. So you have to remember this particular thing also. And when the directing group is not present, then this particular initial CH3 can attack either from the backward side or from the above the plane. Both the possibility is there, like here both the intermediate is generated and both the compound is observed. Both diastereomer has been observed that time. Now let us talk about some other kind of reaction. Like this particular reaction is very, very important. So here it is a triple bond is there. So what happened, that methyl will attack here and this particular bond goes here, and this overall group left the starting material. So we got this type of product as a final one. And also we can see here that SN2 type of reaction has been observed. Here that phenyl nucleophile will directly attack here via SN2 mechanism and the bromine kicks out, and then they got the same product. Similarly, here is also a leaving group there, OTS. Similarly, that particular methyl is show a SN2 reaction, it is substitution reaction, and it will generate this particular product. So with this, we have to end our discussion regarding Gilmann reagent. And I have put a handwritten notes here in the description box, so do check it out, that particular notes also. And in the next class, we talk about the organolithium reagent, and this